Hello and welcome to the 6th episode of our Trigonometry Made Easy series. In the previous episodes, we've covered a variety of trigonometric methods and techniques. In this episode, we will complete the puzzle by putting everything together, demonstrating how to overcome trigonometry problems with confidence and ease. In the problems that follow, we can break up our solution into 3 distinct steps. The first step is to identify your strategy. There's 4 main methods to choose from here: Pythagoras' theorem, the SOHCAHTOA method, the sine rule, and the cosine rule. Once we've chosen our method, step 2 is to label the diagram appropriately and apply the chosen result to form an equation. Step 3 is to use algebra to solve the resulting equation. By focusing on these steps one at a time, even the most complex problems will be broken into much more manageable chunks. Without further ado, let's jump into some examples to see this process in action. In our first example, we have a triangle with sides of 16.5, 18.1 and x. We also have a 69-degree angle. To solve for x, the first step is to identify which method to use. A very useful question to ask here is the following: does the triangle contain a right angle? Pythagoras and SOHCAHTOA require a right angle, whereas the sine rule and cosine rule do not. Since our triangle does not have a right angle, we'll want to use either the sine rule or cosine rule. Now, we should look at how many sides and angles are labelled in the diagram, including the unknown x. The sine rule requires 2 sides and 2 angles, whereas the cosine rule needs 3 sides and 1 angle. In our diagram, we have 3 sides and 1 angle. So here we'll need to opt for the cosine rule. This states that a squared equals b squared plus c squared minus 2bc times the cosine of a. Now that we've identified our method, step 2 is to label our diagram and form an equation. The capital A in our statement refers to the angle. Here, that's 69. Lowercase a corresponds to the side across from this angle, which is x. B and C refer to the other 2 sides, and these can be assigned in either order. Let's let b equal 16.5 and c equal 18.1. When we put in these values, the a squared becomes x squared, the b squared becomes 16.5 squared, and the c squared becomes 18.1 squared. The 2bc cosine of a becomes 2 times 16.5 times 18.1 times the cosine of 69. Now that we've formed our equation, our third and final step is to use some algebra to solve for x. While looking a bit complicated, the right-hand side of our equation does not contain any unknowns, so we can simplify by typing the whole thing into our calculator. This tells us that x squared equals 385.8068. To isolate the x, all we need to do is remove the squared operator. We do this by doing the inverse operation, which is square rooting. Typing the right-hand side into our calculator tells us that x equals 19.6. In our second example, we have side lengths of 3.7 and x. One of the angles is marked as a 90-degree right angle, and another is marked as being 46 degrees. The presence of a right angle means that we'll want to use either Pythagoras or SOHCAHTOA. Pythagoras' theorem involves all three sides of the triangle, but we only have two of the three sides labelled, so this won't be an option. By process of elimination, we'll want to use SOHCAHTOA. There's three ratios to choose from in this method: sine, cos and tan. To figure out which one to use, we should label the sides of our diagram. The hypotenuse is the side across from the right angle. The 46-degree angle should be labelled theta, and the side across from this is labelled as the opposite. The third side is labelled as the adjacent. In our diagram, the opposite corresponds to x, the hypotenuse corresponds to 3.7, and the adjacent does not correspond to anything. Hence, we'll want to choose the ratio which involves the opposite and the hypotenuse. In other words, we should use the statement that sine of theta equals the opposite over the hypotenuse. Putting in the values for our triangle tells us that sine of 46 equals x over 3.7. To solve for x, all we need to do is remove the division of 3.7 from the right-hand side. We do this by multiplying both sides by 3.7. We can type the left-hand side into our calculator to get our final answer. X equals 2.7. In our final example, we are presented with a quadrilateral and asked to find the values of two unknowns, x and y. We have sides labelled with 12, 5 and 9.2. We also have a 90-degree right angle and a 97-degree angle. Let's start by finding the value of x. A key observation here is that our shape can be split into two different triangles, which I've coloured in blue and red. The side labelled x appears in both of these triangles, so we'll need to think about which one of these to focus on. Well, in general, the more things you know, the easier it is to figure out the things you don't know. In the blue triangle, we know two sides, the 12 and the 5. We also know one angle, the 90-degree right angle. So in total, we have three known values. In the red triangle, we only know two quantities, the side length of 9.2 and the angle of 97. We do have another angle labelled as y, but since we don't know the value of y, it's not much good to us. Since we know more information in the blue triangle, it'll be wise to focus here. Since our triangle contains a right angle, we'll want to use Pythagoras or SOHCAHTOA. Focusing on the sides, we'll notice that all three sides are involved. This is the perfect setup to apply Pythagoras. This states that h squared equals a squared plus b squared. H refers to the hypotenuse, which is the side across from the right angle. A and b refer to the other two sides. Here, we can let h equal to x, a equal to 12, and b equal to 5. Putting these values into our statement tells us that x squared equals 12 squared plus 5 squared. This equation can be solved to find the value of x. let's begin with some calculations. 12 squared equals 144, and 5 squared equals 25. When we add these two values, we see that x squared equals 169. Now, to isolate the x, we need to remove the square operator. We do this by taking the square root of both sides. The square root of x squared simply comes out as x, and the square root of 169 is equal to 13. So our final answer is that x equals 13. Now that we've found x, we can turn our attention to y. Again, we'll need to pick which of the two triangles to focus on. However, the decision is easy here. We'll want to pick the upper triangle since this is the only one which contains the angle y. This triangle does not contain a right angle. This limits us to either the sine rule or the cosine rule. To distinguish between them, we should count up how many sides and angles are involved. In our triangle, we have 2 sides and 2 angles. This is the setup for the sine rule. A over sine of capital A equals B over sine of capital B. To apply this statement, we should first label our diagram. We label our first side angle pair as capital A, little a. We label our second side angle pair as capital B, little b. Here, capital A equals 97, little a equals 13, capital B equals y, and little b equals 9.2. When we input these values into the sine rule, we get 13 over sine of 97 equals 9.2 over sine of y. From here, we can use some algebra to find the value of y. It's a little bit awkward having the y underneath the line in a fraction, so let's begin by flipping both sides of the equation. Next, we can remove the division of 9.2 by multiplying both sides by 9.2. Typing the left-hand side into our calculator, we see that 0.7024 equals the sine of y. Now, to remove the sine function from the right-hand side, we should take the inverse sine of both sides. Typing the left-hand side into our calculator brings us to our final answer. Y equals 44.6 degrees. To finish off this video, it's time for you to try some exercises using pen and paper. The answers can be found in the video description.